Welcome to today's tutorial. Let us discuss a few things that require a bit more explanation and some uh, hands-on example or worked example for the sake of understanding. Now, we've gone through a bit in the last few lectures. One of the things we went through was the mathematical language. Before that was the basic information about solids. We've gone through the mathematical language definitions on how you describe a solid. We've talked about the bonding and how it happens, including things like the range of attractive versus the range of repulsive forces. Now, the other thing that will be important, of course, is to move on to the next step, which is to think clearly about more about the lattice and some of the tangible operations that we can do, mathematical or otherwise, to describe a crystal. One of these things is, of course, describing the symmetry of a structure. To do this, we of course introduced a bit of mathematical language to help us understand what is going on. So let's now think about a bit more about the ideas of groups and how the operations under a particular group, to understand what they are and how they can be useful to us. We will not go too much into detail on groups, but still some introduction is necessary. Now, if we start from the idea of a lattice, we remember that the definition of a lattice is an infinite array of points that's obtained from the primitive translation vectors. Now, the translation vector is a vector joining any two pair of lattice points. So, by definition, if you join any two lattice points, the vector that's joining them is a translation vector. Now, if you were to take the set of all translation vectors and group them together, you would call this the translation group of the lattice. So this is an example of a group, but it is not the only example. What is a group? So from linear algebra, or from the theory of set, a set of elements of any kind which have a particular set of operations by which you can combine these different elements can be called a group if some conditions are satisfied. The first condition is that any two products of the product of any two elements in the group will belong to the group. The associativity law holds, identity elements is in the group, and every element in the group has an inverse. If all of these are satisfied, then you can call that set a group. Now, in addition to the translation group that I've already given as an example, you can also have what are known as point groups. Now, what are point groups? Point groups, let's think about the symmetry operations that would leave a lattice unchanged. These operations could be rotations, inversions, reflections, and so on. These are what would form the point group of that lattice. Now, in the example that I am giving, you can see a simple lattice, and on this lattice we can be able to perform a few types of operations that leave the original lattice unchanged. The first being the identity operation. The second one will be rotation by plus or minus 90 degrees. We could have a rotation by 180 degrees, reflection about the x or y axis, and finally a reflection about the x equal plus minus y axis. Now, these are more or less some of the operations that would leave this lattice unchanged. And these are the kind of operations we expect in the point group of our square lattice, this example that I have given. Now, in the next section, we are going to talk a bit about the concept of allowed rotation. So we will take one of these operations in the point group and try to understand a bit more about it in detail. So this will be dealing with the idea of why we have to rotate by 90 degrees or 180 degrees and not by, for example, 30 degrees or 20 degrees or 85 degrees.